Welcome back for part 2 of our Introduction to C++ Programming. And as you can see, I've zoomed into the code that we had before. And this, of course, is the mandatory required hello world that all programming languages seem to do before they get into the deeper stuff. And what do we have here? Well, we have our first C++ programming. Line 1 tells you that on line 1 there is the pound include, which is the pre-compiler directive, the pound. The language saying include means to go out and find. The library, IOStream. The alligators tell you on either side that it's found in the system libraries, so our IOStream library, as opposed to somewhere else in particular. So this says include this code so we can use it to run parts of our program, predominantly things dealing with input and output. Below it, starting on line 3 and running through line 6, is our main function. We know it's a function basically because of the parentheses beside the word main. That kind of is a clue. The block of code symbols, the braces that are on either side, the curly braces, or I like to call them mustaches. The int in front of it is a shorthand way of saying integer. It's a keyword of our programming language. So this says this is the main function. Here's the code, and I expect after the function is over with to get an integer number back from the calling program from this function. So the fact that something's coming back means that you've got to have a corresponding return that says return something that is an integer, in this case 0. And if you look way down below, you'll see process finished with exit code 0. That means CLion ran this code. When it finished, the code returned to 0, and it's telling you that the exit code was 0. If we change this number here, this number down here changes to match whatever was returned to CLion. And if you've ever had a Windows program or other program crash and you see an error message that pops up saying error message 422, that's what's happened. Somewhere along the way, it's returned a value to the calling function or the operating system telling it what's going on. Now our code also has built into this thing, the braces mean block of code. Start here and here. It isolates chunks of code to be contained within a function or another block of code for other things that we'll discover later on. Now, the way this program is working, the only two lines that we have of real code here are lines 4 and line 5. Now the syntax and the semantics are the parts of code that tell you not only what words are we using, are they correct, and the semantics is the meaning valid. The compiler judges all of that when it goes through. You're being judged silently by a compiler. So a sentence in C++ ends in a semicolon. Not every line, but every sentence that is correct. So if you have the correct syntax, you put the nouns and the verbs in the right spot, and the correct semantics, the compiler will process that and generate machine code via object code and through a linker that you can run on your computer, and you'll see the output. See, there's hello world. So our output is this word right here, cout. Generate to the standard out whatever follows that command. What follows that command is a couple of alligators pointing towards out that says print this string literal. A string is a collection of characters, more than one. It can be one, but more than one generally, surrounded by quotes or 2 tick marks on either side. So the tick marks say hello world is a string. This string is now taken, processed, and pushed into the standard output, in our case, the screen. Once it gets to the screen, you'll see, look, hello world. After that, we have another set of alligators, less than symbols, that say generate an end line character. Well, the end line is a carriage return line feed, which means put the cursor back at the beginning and drop it down one, and you'll see we actually ended up with it down here. It's not currently running, so you can't see it, but that's what this is showing. Now, the STD stands for standard. Most namespaces or chunks of code, you can think of it like last names to identify huge chunks of code. Inside our libraries, a lot of them belong to the standard namespace. There are lots of namespaces. You can make your own, but for now, just understand that standard is the standard namespace. The double colon behind the standard says this is the namespace resolution operator, which means go forth and find in this namespace this thing right here. So what we've done is we've told the code, go look up here because we didn't write this piece of code. It's actually been given to us. We didn't write it. You're not going to find it inside our function. Go up here and find it. So the standard colon is the way of saying where to go find something you didn't write. Same thing's true for the end line command. Go into the standard namespace and find this thing right here. So in this case, it says, go to the standard namespace, find the cout command, output to the standard output the string literal, hello world. It literally does not change every time we run the program. And then give me an end line or a new line carriage return line feed kind of thing. And then when that line is done, return to the calling program A0. So this is what this piece of code does. As a quick discussion, you'll see in the Gaddis textbook and other textbooks this line. Using namespace standard. This is now considered to be a security risk, and we don't do it anymore because this opens up the complete namespace to anything inside our code. If you use this, you don't need these guys right here. All you need is the cout. And that will automatically go and say, hey, if I can't find it in your code, I'll go look in the standard namespaces of every library you've included until I find one and then use it. So generally speaking now, we don't do this anymore. The rule of thumb, at least in this class, and for a lot of people, is to not include namespace standard. If you go on Stack Overflow or some other places, you'll find a lot of information about why that's considered bad and some good discussion on the pros and cons of doing or not doing that. And in this, we've covered the basics of what this code is, the basic pieces of the puzzle. So review it, try to make some changes, and see what happens. Coming back soon with part 3.